Okay, so welcome back, ladies and gentlemen. Thank you very much, firstly, for allowing me to speak to you guys today. I wear many hats within my industry, and there was an interesting question earlier on this morning about, was engineering your chosen career? I didn't put my hand up because I didn't choose to be an engineer, and I did not choose not to be an engineer. I accidentally became an engineer. I went to university to study illustration because I enjoyed taking things apart and drawing them. But halfway through my first year, I ran out of money because I did what most students do and spent it all on beer and partying, which is exactly what you do. So I went off and joined the Army Reserves. And the unit that I joined had an assault pioneer unit. And part of the way through my time at university, the Bosnian conflict flicked up, and there was a massive humanitarian problem happening in that part of the world, and I felt it was my duty to go and help them. So I volunteered to go out and help put right a lot of the damaged water courses, repairing buildings and putting sanitation and things into some of the cities. So I didn't actually choose to be an engineer. I had a go at it, as it were, out with the assault pioneers in Bosnia. Loved it so much that when I got back, I decided not to complete my education and I went off to become an engineer. But I started on site and worked up from there. So what type of engineer am I? I suppose I started off being a civil engineer, looking at highways and railways, doing work on site itself, and then into the design office, and then into the managerial office. And then I sort of accidentally became a digital engineer, which is what we see today, which is very prevalent. I run, since 2012, the BIM Advancement Academies for Crossrail and for an organisation called the Bentley Institute. Now, this was part of my role that was asked to perform by the UK government, being part of the BIM task group and being driven into some of the larger projects and helping them to work out their digital strategies. So as everyone else has had some sort of nuclear connection, I'll put my hand up and say I helped create some of the digital strategy for Hinkley Point, which was very interesting indeed. And I think one of the really cool things I've done as a civil engineer is stand on Tottenham Court Road station when the tunnel boring machine came through above the platform about 900 mil off the top of the tunnel. You could hear the voices of the people in the tunnel boring machine whilst you were standing on the platform only about 12 foot below them. And you couldn't do that with without good information, and that's what drives me at the moment in my digital engineering world. So I wanted to correct something that came up just before the last break about this BIM thing. Okay, so sitting on the BIM task group, driving the digital construction strategy for the UK, BIM is not CAD. End of story. It's not a 3D pretty picture. It's not a 3D pretty picture with information attached to it. Okay, it is a data model that helps us to make good decisions. It helps us to drive that tunnel boring machine over the top of that railway. It helps us to make those safety decisions in the nuclear power plants. And it helps us to make those design decisions on board the boat or the structural engineering or whatever that might be. But it takes us all the way through that life cycle. All the way from the point where I imagine I need something, all the way to the point that I dispose of that thing. And that's part of my role with the government on the Digital Built Britain. I run some other organisations as well. One of the interesting ones, also mentioned this morning, I'm an ambassador for the Bloodhound Supersonic Car Engineering Team, and that is getting my car up to 1,050 miles an hour on the Haxan Pan at the end of next year. Fingers crossed. We keep having funding problems within there. So yeah. And I also do quite a bit of work with the British Army as a reservist now and for the last 25 years. So what I want to talk to you about today is an organisation that has been close to my heart now for about 14 years. It was born out of something called the Egan Report. Who here has read or knows what the Egan Report is? Okay, so not many people. Okay, so report created 1998. It reported back basically that my industry, the construction industry, was a very backward, very risk averse, very technologically unaware organisation and industry that needed to be brought forward into the 21st century. So the Department of Trade and Industry asked me to create an organisation that would help them to drive change in my industry, introduce innovations, and to make us more technologically aware. Now, as you know, our industry is an exceedingly conservative industry, risk averse, doesn't like spending money if somebody hasn't already proven the fact that it will give me an ROI. So it's not an easy job to do. Most recently, has anybody read the Farmer Review? Oh, blimey, okay. Had that really important statement at the bottom of it. Modernise or die. Simple as that. It predicts the destruction or complete annihilation of the Tier 1 contracting community if we do not start embracing new technology, innovations and change. If we do not change the way we are actually carrying out our work, our procurement strategies, the way we deal with our contracts, it really says doom and gloom if we don't get off our backsides and do something about it. And the only way we can do this is things where we have change is strong leadership. I was very lucky working on the Crossrail project to have a guy right at the top called Sir Andrew Wolstenholme. So Andrew is a very important, influential person right at the top of that organisation who was part of the construction strategy written by the government. And he drove that change within that organisation. And we see if you don't have somebody at the top who will press that button and say, you will do it, it doesn't happen. People at the bottom have wonderful ideas, but unless the person at the top says, yes, you can go and do it, it's never really going to happen. We need to have active encouragement. How many of you are graduate engineers who've been out on the construction site? Okay, one or two. So you've all had some good ideas, and you've probably gone to your project manager and gone, hey, I've got a wonderful idea. This is great. It's going to save us loads of money. And that project manager's gone, yeah, well, there's a lot of risk in deploying that. Not on my project. I haven't got the money or the budget or the time or the effort or whatever it is to do that. We've got to change that culture. We've got to dispel that problem that we have on those sites. So we've got to actively encourage people to get on with that. I've seen a lot of change in that in the recent innovations programs within the contractors, which is great. We can't just keep things to ourselves anymore. What we found is when a project manager found a wonderful piece of innovation, they kept it on their project and they wouldn't tell anybody else because they wanted to be the best project out there and keep repeating being the best project manager. So they get the bonuses and the awards and whatever it might be. But that's no good for a business. We need to have these changes across an entire industry. So we need to be able to make people aware and share knowledge. And then finally, we've got to enable people to actually do the job, because it is a very difficult job being a project manager on a construction site. Okay, there's a lot of pressure to get the thing on time and on budget. They don't have time to project manage an additional innovations project as well. So therefore we've had a lot of the contractors now have an additional innovations team or champion to actually go on site and help these people to deliver that, which is great. So some good positive steps as we go forward. So COMIT as an organisation are all these organisations. So we have contractors, we have technology companies, and we have the academia, and we have clients and owners and governmental organisations all coming together to try and solve this problem. And the way we do that is that somebody identifies a need. Somebody says, I think we've got a problem, or hey, well, maybe we could do something differently. We select projects that this can be done on. So we bring together a client, a contractor, a technology vendor, maybe a subcontractor, maybe a university to partner to try and do a pilot project to solve the problem. We understand the business value in there because that's really important. If there's no business value in delivering something, why bother doing it? It might be your own personal hobby horse that says, I've got this cool bit of technology that I think I can solve a problem with. But if the problem is not costing us in time, health and safety, money, or whatever is on that site, then let's just step back a bit and work out what the real value is. Conduct proof of concept projects where nobody's exchanging any money. It's a case of people put time and effort in to try and solve a problem using new innovative technologies. Measure the business value, because we've got to be able to arm everybody in the organisation with enough information to go to that project manager in their organisation and go, boss, look, we can do this new technology, we can do this new innovation, we can change the process of what we're doing, and this is how much it's going to cost, and this is the return on investment we're going to get. Oh, and by the way, these are the business changes we need to make. Right, okay, happy with that. Somebody's already done it. I don't want to be the first mouse, because the first mouse doesn't normally get the cheese. They get their head caved in. And then we try and drive adoption throughout the industry by publicising those case studies. So I've picked a quick life cycle of an asset and taken some of the innovations and things that we are dealing with within COMIT to describe what they are. So the first one, we need to think about the kind of like data, decisions, the questions and things we need to do to carry out the tasks. Well, all of this is about the BIM world. Okay. Before we start looking at technology, and I was really quite pleased, whereas whoever's statement was in the last presentation, that it's not about the tech, it's about the process. Okay, and the information behind it. We need to set that information. We need to look at our asset breakdown structures, look at the impacts and relationships. We've got to look at our asset tagging strategies, which give us our functions over our products. And then we've got to look at the questions that we need to ask all the way through the life cycle of that asset, so we can actually get some answers which will help us to make good decisions, which means we can be more efficient in the way that we procure our assets. So COMIT is very heavily involved in this in the education side, not for the big guys, which we do help out on the tier 1 and the government side, but for the smaller supply chain. The people who it's really impacting at the moment are the fabricators, the manufacturers, the logistics guys, the subcontractors, the people who haven't got the time and effort and money to actually invest in this stuff right at the very beginning. So we also work with the UK government to deliver what we call the 8 pillars of BIM, and we're involved in all the standard creations, the 1192s, the 8536s, the 41s, the PAS Part 5s, all about security. And I'm probably talking absolute gibberish to a lot of you in this room, but there are some standards in there which are mandated by the British government. Okay, and if you don't do them, well, yeah, there's going to be problems. And we help people to understand that and also potentially deploy technologies to help them to do it. So has anybody here heard of blockchain? Yeah. So it's not something that's well known by a lot of people. In fact, some people have heard of it. I'm not quite sure what it is and what it does. But I sort of explain blockchain in a really simplistic manner, because I have to explain it to quite a few people in the industry, myself included, so I've got to understand it first, so it's got to be simple. So blockchain to me, okay, is like my mother when I was a child. Okay, my mother when I was a child knew where I was going, who I'd been with, where I'd been, and had actually documented my entire childhood with photographs and albums and stickers and things that I'd drawn and all sorts of stuff. That's what blockchain will do for your information. Whether it's financial information, whether it's construction information, or whether potentially it's information being delivered over a secure military network. It will make sure that you can validate that information and know that you can trust it. So we start our journey when we get onto site with a basic collection of information. And we've been involved in lots of projects around drones, whether they be ones UAVs in the air, whether it be waterborne, whether it be landborne, for collecting information right from the very beginning. Now the video you see there is us having a bit of experiment with a drone using photogrammetry. It's captured in around about half an hour on a cold, wet and windy February morning. That is Plumstead Depot, so it's a live running railway, it's a live construction site, it's in the flight path of London City Airport, and it's next to a prison. So we picked all the really difficult things to do because we needed to prove that construction could do it and have enough money and return on the investment from the information that we were gathering. So we've been working a little bit with the photogrammetry world. We've also been working with these guys here, GeoSlam, to create internal mapping of buildings, allowing us to get visualizations. So that's a photogrammetry and laser scan on a handheld device. So some really interesting basic stuff to collect basic collection of information before we need to start doing things. So one of the problems we've had and we've faced in COMIT for many years is communications. Has anybody here set up IT or communications on a construction site? No, okay, so, oh, good. So you probably understand the problems we have with BT OpenReach and the fact as soon as you run the bid to be on that site, it will take you 12 weeks minimum to actually for somebody to come up and connect that last 5 meters of copper cable from the box to your site office. 12 weeks. But if you wait 12 weeks to start up on that site, you're losing a lot of time, effort and money. Okay, a lot of money. So we need to find best ways of getting more data and everything onto that site, communications onto the site. Problem is, of course, 15 years ago when we started this, communications was quite small. We were sending little packets of information, maybe a document, maybe a PDF, and we were talking to each other over a normal phone. Now we're not. We're sending massive 3D visualizations, we're sending voice over IP, we're delivering massive packets of data, and so we've got to change the way we do things. So we're working with a lot of technology companies to do satellite multiplexing 3G cards, even quite an interesting one where we're using the low voltage power network that you put down on a construction site as the communications package to deliver communications around the site. Incidentally, what we're doing, interesting experiment with that, is in the emergency world, if we've got a city which is down and we're going to go in for humanitarian needs, we can use the copper cabling that delivers the power to that city, actually, to deliver the communications that we need to make sure we're delivering the humanitarian supplies, the food, the water, etc., to the right locations at the right time. So some really interesting thinking. So we go back into the continued collection of data and the analysis of that data. So a couple of interesting projects that COMIT have been working on recently, carrying on the photogrammetry world, was we stuck GoPro cameras on a crane. Okay, so the crane takes photographs all day, every day, because you've got a GoPro just sitting on there. Takes a photograph every couple of seconds. And what's cool about that, at the end of the day, you just transmit that information down onto your machine and create a photogrammetry of that site. And then you do it tomorrow, and you do it the following day, do it the following day. For a couple of £100 worth of GoPro camera, we've now got a complete build-up, as built, of that site from day one. Yeah, that's pretty cool. I like that sitting on there. So we took that a little bit further, and we did it in wearables. So we got some poor guy in the office. Yep. Okay, this Michael did this for me. Poor old Michael. And we stuck GoPros on his shoulders, and his chest and his back, and on his helmet and everything, and he walked around the construction site all day just doing normal stuff, doing inspections, whatever it might be, and by the end of the day we downloaded all the photogrammetry and we got a complete photogrammetric record to about 30 millimeter accuracy of that site, which once again, for the cost of a few GoPro cameras, pretty cool. That's not a bad thing to do. So that wearable stuff is something that is a project that we're doing a lot of at the moment. Taking things like earbuds which detect your heart rate and your health on the construction site, because I need to know that you're a healthy construction worker. I need to know that you're not panicking about something, that your heart rate is not going up because you're in danger, or your heart rate has stopped because you've had an accident on that site. what those buds can do that we've been working with the manufacturer to understand about is also test CDT to make sure that you've not been taking drugs, that you've not been drinking the night before. Because I want a construction site that's safe. I don't want to be on a construction site where you've got a hangover and you accidentally do something with that crane or that piece of equipment. All right? I don't want to have any accidents on my sites. So you don't know anybody come across the Atmo. It's a piece of tech we've trialled recently. Basically, it clips onto your body. You walk around a city and it's taking pollution monitoring all the time. So that links to your phone, which links to a geospatial network, which means that when you look at that device, you can see where the pollution is within the city. So if you've got bad lungs, which a lot of people have, you can choose the best route around the city to avoid the pollution. That's not bad. But hell, why don't you do that for a construction site as well? So you can monitor the places where gases are collecting and map the site to find where you need to start putting proper ventilation in. We did some interesting experiments with social media on that as well within the city. We looked at all the positive tweets within the city and all the negative tweets within the city and worked out within the city where the happy people were. Cool. But what's really good about that is we worked out that a lot of the grumpy people were next to construction sites. Why is that? Is it because of the noise? Is it because of the pollution? Is it because of the fact they're being diverted onto other pavements so they can't walk down particular things? It gives us another level of information to analyse and react to. Hey, we talked about that earlier, wasn't it? Oh, it was that BIM thing, wasn't it? It's all about information, making a smart decision to help us to improve the world that we live in. So sensors are another thing in there. Putting sensors on everything, really important. They're pennies, they're really cheap. You can embed them, we put them in tunnel rings on Crossrail. But the point is the information you're collecting now is going to be important in 10 years' time when you're looking at trend analysis as to why did that building fall down? Why did that generator stop working? Why did that thing catch fire? And the last bit on there was really, really scary, was the photogrammetry side. We did some image recognition of people. So we could actually know where people were on that site when the photographs were taken, and we could recognise what person it was because of facial recognition, and then be able to put a list of all the people who've been in the wrong place, as in they walked in to dangerous zones rather than walking around the outside properly. They've been skipping across the bits they weren't allowed to, and we were picking them up on the photogrammetry during the day, and then putting a rogues gallery in the canteen at the end of the day, which some people might say that's an invasion of privacy. I say that's helping to stop you kill yourselves on a construction site. So, delivering information to the workforce, we do a lot of work with AR and VR, taking that information which is in our data models and allowing people to visualize it and consume it at the point of work. Maintenance engineers are probably the people that nobody wants to be. We talked earlier on about what type of engineers we were, whether we were automotive engineers, aerospace engineers, we were structural engineers, we were civil engineers. But by the time you get down to the bottom of that pile and we say maintenance engineers, who wants to be a maintenance engineer? No, deadly silent. Oh, splendid, excellent, really pleased to see that, because these guys are so important. They have the capability of keeping our assets running for the next 150 years. The structural guy might have a couple of months on it. The construction person might only have perhaps 6 months to a year on it. The maintenance engineer will spend an entire lifetime making sure that thing works for the good and the function that it was designed for in the first place. And we've got to be able to give them information to consume at the correct way all the way through that life cycle. So we work with a lot of companies looking at, say, VR and AR, trying to allow people to consume information in the way that they want to do so. So we're working a lot with companies looking at artificial intelligence. Now, AI has got a lot of press of late. Lots of really, really clever people doing things with AI. A hell of a lot clever than I am. I will certainly claim not to have any knowledge of how it works. All I know is that we're doing some pretty cool stuff with it. So anybody back from the 1990s remember this little paperclip? Yeah, okay. Picked up on your Word document and said, hey, you're writing a letter. Do you want some help? And you always went, no, get out of here. But actually, if you think about that nowadays, if we've got a common data environment, all the information we understand about that particular asset, if I started designing something in one location, it could go, oh, I see you're designing a bridge pier. Ah, other people who've designed a bridge pier have used these calculations, these standards. They've used this information. Did you know about this area? There's a X warning on this. There are these things in there. Hey, that might be a good idea. Oh, and by the way, somebody else is already designing something in that location, so perhaps you ought to give them a ring. Hell, I like that. That's pretty cool. So being able to help people without them actually asking for help are the kind of things that artificial intelligence will help us do later on. It might be a case that we need to use that with things like Amazon Echo. So instead of having to search for information in our database, when something's being delivered, how much is it costing, what the calculations for X, Y, and Z, perhaps we just press the button on our device and go, Siri, is that thing going to be delivered today? No? Okay, thank you. Siri, how much is my contract actually costing me at the moment? Oh, and what about subcontractor X? Is subcontractor Y actually on site at the moment? And it comes back with all that information because it's the data model behind it that's giving the information to help us to ask the questions and make the decisions. I know I'm rapidly running out of time here, so I won't talk about the factory in the box guys, but that is really cool. Look them up on the internet, Bryden Wood, okay, and they are delivering factories to Africa in a box, pre-constructed as it were, but in parts, a bit like an IKEA flat pack factory. So it can be put together by 4 or 5 people who know nothing about construction but know how to put together furniture because they put the red slot in the red hole and do the bolts up, and that's it. Fantastic. I can produce a factory in a very short amount of time because it's been designed and manufactured off site, and all it needs to be is assembled. And the final one is we've been working with people about as-built delivery, making sure they get the correct information, they understand the impact of that information on operations and maintenance. And a little bit of cool tech we've been doing here with Crossrail is a project where we send, so normally a maintenance engineer has to walk down the track every night to see what's wrong with the tunnel and inspect things. That's dangerous, it's unsociable, it's not particularly the kind of job anybody wants to do. So we're not recruiting very well in that area. So now what we're doing on the front of the train, we've got photogrammetry, we've got laser scan, goes down the tunnel every day, and instead of the guy having to walk down the tunnel in unsociable hours, they walk down a virtual tunnel in their the virtual reality suite in a comfortable office with a pint of tea in one hand and a bacon sandwich in the other hand. Awesome. Okay. It really is a massive change in how we're doing things. And because it's connected to that database, that data model of information behind it, it allows us to make those decisions, the things that we're doing. So leading the last 60 seconds to the engineering world of the military, we mapped this across when I was doing some work for the Royal School of Military Engineering of what technologies we are using in the construction industry at the moment could you potentially use in the military engineering world. And the fact that we set our strategy, tactics, doctrine, etc. with the construction world, with our Digital Built Britain strategies and our standards. We carry out basic reconnaissance of our sites, collecting information, digital information. We set up communications infrastructure to send and transmit that information. We carry out analysis on things and do planning for work packages to deliver deliver engineering and consumables. Same thing with humanitarian operations. We push information to people, so we're looking at orders delivery, rehearsals and live updates to people who are actually carrying out tasks on site. We allow people to talk to the database and say, well, when is this arriving? What is this here? Tell me more about that. Giving strategic and tactical support to the people on the ground, and then being able to support that operational life cycle with the ability to take people away from the dangerous areas and have people who are experts behind the scenes whilst the engineers on the ground carry that out. So the COMIT organisation, we do a lot of things around Europe and within the UK. We get involved in a lot of organisations, supporting the government and supporting the industry. Every one of you in this room who's a student, you're already members of the COMIT organisation because your universities are affiliates to it. So if you want to come along to any of our community days or our events, then please do. It's free to you guys. Okay, ICE is one of our partners. British Military are one of our members. So yeah, blimey, come along and get involved. It really is not a bad thing to do. Always, thank you very much for that. I'm sure when the panel comes along in a bit, I can answer any questions that you might have because I think we're running just a little short of time. So great, thank you very much.